Hello everyone, today we are going to solve question number 143, reorder list. You are given the head of a single linked list. The list can be represented as in this format. Okay, you have to reorder this list in this following format. Okay, and you can observe here the format says that once you have the first element, then you have to insert the last element. Then you have the second element, then you have the second last element. Okay, you can see in the example here 1, then 4, then 2, then 3. Okay, so this is the format. This is another example where 1, 2, 3, 4, 5. So the answer should be 1, then 5, then 2, then 4, then 3. Okay, so 1, 5, 2, 4, 3. Okay, so in this video, I'm going to discuss two methods to solve this question. The first one is going to be like your main intuition behind how to solve this question. This method is not going to follow this rule where you may not modify the values inside the list node when the node themselves may be changed. Okay, so let's see how this problem goes. Basically, our goal of this question is going to be to manipulate this list in the provided format. Okay, as we have discussed the format. Okay, so first thing this question that comes in my mind is we have this idea where we can store the elements inside an array and then we can recreate this linked list. Okay, so to follow this method, these are the three steps. You're going to store, then you're going to recreate this list, and you cannot update it because obviously it's against the question. You can see you may not modify the values. So either you can recreate a list, you may update it, it gives the right answer. Okay, and in the end you have to return the answer, although it's not true. The function is void, so we don't have to return anything. Okay, so let's see how this method actually look like. Okay, so this is a list, linked list that has 5 elements inside it. What we are going to do is we are going to convert it into this array. Okay, then we will keep 2 pointers and then going to rebuild a list or like change the values in such a manner where first element is from I, then second element is from J, and then we move them. Okay, so this same way, or we moved them again. We fill 1, 2, 1, 5, 2, 4, and then again when both of these are pointing at the same one, in that case we are going to just fill one of them. Okay, so this should be the code. Let's see how we're going to implement it. Okay, so first thing that we'll need is a vector. Okay, so vector int ar. Okay, let's have some space over here. Okay, next what we'll need is we have to fill this array. Okay, so list node star temp is equal to head. After this, while temp is not equal to null, or you can write while temp ar dot push back temp's value, and then temp is equal to temp's next. Okay, after this we have in our case you can see we'll need two pointers. Okay, I and j, so we'll write these pointers. So int I is equal to 0 and j is equal to arr dot size minus 1. Okay, this now points to the last element and this points to the first element. Okay, now we'll refresh our temp, so temp is equal to head again. Okay, now while I is less than equal to j. Okay, why is this case? Because you can see here there's a condition where if the number of elements inside the array or list are odd, in that case I and j will point to same element. Okay, hence we have to write I less than equal to j. We are moving them close one by one. Okay, first thing first, we'll fill the value from I. So temp's value is equal to AR of I. Then I'll do an I plus plus to move our pointer. Then temp is equal to temp's next. Okay. Now here's an important condition where if temp is not equal to null, in that case only we are going to do temp's value is equal to AR of I, oh sorry, AR of j minus minus temp is equal to temp's next. Okay, So this should do it. So what we are doing is we are creating an array. We are iterating over the list, and we are filling all the elements inside this array. We have started two pointers I and j on array, and we are filling this original list with the elements according to our needs. Okay, this is the simple process behind it, and we don't have to return anything because it's a void function. Okay, so you might think, why this condition? This is because you can see we inserted the first element. You can see here, inserted the first element. Okay, we inserted the second element from this. Okay, inserted the second element, the third element, the fourth element, the third element, the fourth element. Now the fifth element comes from this one. Okay, the fifth element comes from this one. After this, we don't have any nodes inside this list. Okay, hence if we again do a temp val equal to AR of j, it's going to give us error. So we should know how many elements have, so that we actually have an element after this. Okay, so for that we are using this if temp of val is not equal to null. Okay, why this case is happening? Because I equal j. So in this case, you can see 3 is going to be pushed twice because I also points to it and j also points to it. Hence, once I have placed I have placed it using I don't want again. Okay, and this is a simple condition that's going to check it. Okay, let's run this. Okay, let's submit this. So you can see we have solved this question using of n time complexity and of space complexity. Let's move to next method. So now we are going to see the actual method or the most optimal solution for this problem. This method is going to be divide and combine. Okay, so let's see this method. The time complexity for this method is going to be O of n, and space complexity is going to be O of 1. Okay, let's see how this works. First thing first, you can notice that in the original, like we discussed in the previous video, where we solved a palindrome linked list problem. In that video, we had an ideology where if we split the list and then reverse the list, we can do a lot more comparisons. Okay, the same principles are being applied in this question also. Okay, the core idea behind this method is going to be, first thing, that will cut the list in half. Okay, then we're going to reverse the second part, and then we're going to reconnect accordingly. Okay, you can imagine here, this is the visualization part. Okay, so this is a list. Okay, I used slow and fast pointer to reach the middle of the list. Okay, I have splitted this list into two parts, where the first part carries these three nodes and the second part carries these two nodes. Okay, now what I'm going to do is, this node stays as it is. This node is going to be reversed. Okay, so after reversing, this is going to look like this. 4 and 5 are now going to be 5 and 4. Okay, now we're going to combine these. Okay, so to combine these, this is how it actually looks. Okay, first have head. This is going to point to head 2. We are going to store it somewhere, and then this head 2 is going to point to this, and then this is going to point to this. Okay, so in this way we are going to rebuild our array and a linked list. Okay, and you can see the actual it matches our actual answer. This is 1 5 2 4 3, and you can see 1 5 2 4 3. Okay, so that should do it. The task for achieving this method are going to be, first traverse over the middle of the linked list and split it into two. Then we are going to reverse the second half of the list. Then we are going to store, connect, and traverse. Okay, so let's see how this method works. Okay, so one thing you can see that I have this function added over here, which is going to be reverse list. Okay, what this function does is, you have this list uh, that we provided, and it returns a reverse list and its head. Okay, so this is a very simple function. We have written this function almost 5 to 6 times. Okay, so what it does is it has a previous, it has a current. While current is not equal to null, what you're going to do is you're going to store the future, you're going to reverse the current part, and then you're going to just move all these pointers. Okay, it's a very simple function. Okay, one thing that we have stored with us. Next, what you'll need is uh, we need to divide this. Okay, so to divide this list, we'll have a slow and fast pointer method. So let's node slow is equal to head. List node star fast is equal to head. Okay. Now the simple method where while fast and then fast next. Okay, slow is equal to slows next. Okay, and fast is equal to fast next next. Okay. So we have written a slow and fast pointer. Once fast reaches the end of the list, slow reaches the middle of the list. Okay. Now since we have slow at the middle of the list, you can see here, once the slow is at the middle of the list, we have to disconnect this part. Okay, so I'm going to store this part. So list node star new head, or you can say head 2 is equal to uh, slows next. Okay, slows next. Okay, and I'm going to do slows next is equal to null, or you can say null pointer. This way I have disconnected these lists. This is head 2 and this is our original head 1. This is head 2. Okay. So slow and fast are done. Now what we'll need is we need to combine, first we need to reverse this list. Okay, this part you can see here. We have to reverse this one. Okay. So to this, so we have already have a function which returns a head. So I'm again going to store it to head 2. Head 2 is going is equal to reverse list head 2. Okay, head 2. Okay, so we'll have a reverse list with us and its head is going to be stored in head 2. Okay. Now our main function that comes is going to be this one, which is going to help us connect our list in this format. Okay, so let's see how this one works. I'm going to write a function out of it. So I'm just going to write a combine list, something like this. I'll pass head and head 2. Okay, I'll pass these, and since this is going to return me a head, so I'm just going to write it like this. Combine head is going to return head and head 2. Okay. Now we'll have list node star combine head, or sorry, combine list node star head 1, list node star head 2. So I'm going to copy this and paste, and sorry, and control V. Yeah, so this is going to be head and this is going to be head 2. I'm going to use separate names for them. So list node star temp1 is equal to head, and list node star temp2 is equal to head 2. Okay, simple. Now we'll need a similar loop while temp1 and temp2. If either of these are empty, we are going to end our loop. Okay, and deliberately we have keeping the first list bigger. Okay, this is by design that we have kept the first list bigger, so that we don't have an edge case where we'll leave one element behind. Okay, and this happens in odd case where we have odd number of elements inside this list. In that case, if we keep these three elements as you can say half part, second half part, in that case we'll have an edge case where this 3 will be left behind. In that case, hence we have designed this in such a way that we'll keep these two elements inside a separate list and these three together. Okay, so list 1 is going to be always bigger or equal to than list 2. Okay, now first thing that we'll need is while. So what we need to do here is temp1 is going to point to temp2, but before that we'll store it somewhere so that we can have access to this one. Okay, so list node star store1 is going to be temp1's next. Okay, now temp1's next is equal to temp2. Okay, you can see here temp1's next is going to be temp2. Okay, now for the next iteration we'll do the same thing again. Okay, so first we'll store for this head2 and then we're going to move it to this one. Okay, so list node star temp store 2 is equal to temp2's next. Okay, now temp2 is next is equal to store1, not temp1. Okay, you can see temp2's next is going to be store1, which is which we are storing here. Okay, now after these we'll update the values of temp1 and temp2. Okay, so temp1 is equal to store1 and temp2 is equal to store2. Okay, and after these we'll just return head. And why we are returning head? Because we have designed that first element is going to start from head and the larger element, the larger list is going to be the first one. Okay, so this should do it. Let's run this. I think there's no gaps here. Let's run this. Okay, let's submit this. So this method has time complexity of n and space complexity of n, and we have completed all the test cases. So that's it for video. Thank you.